Hello, welcome back to this segment. Today I will talk about the difference between inc and add instructions. Okay, let's get started. So I wrote a little assembly code to illustrate the difference between inc and add instructions. So here's the key. Suppose I have a number, say FF in hex, which means all bits are 1, all the 32 bits are 1. And I'm not trying to increment that number. Okay, and I do the same with add, using add. So I transfer the same number to AX and increment 1 to the AX. So these two instructions essentially achieve the same goal, right? Increment this number by 1. That's the meaning of increment. Adding by 1 is same as incrementing the number by 1. Okay. All right. So given this, what is the difference between inc and add? Let me show it to you. So let me first compile this and then load it into GDB, disassemble it. It's the same code that we wrote, and put breakpoint at 2 places. I want to put a breakpoint at this place first before the inc runs, and print the state of the flags. Okay. So far, only the interrupt flag is on. We don't care about the interrupt flag at this point. No worries. Let's move on to the next instruction, which is basically the inc instruction. And we can see that we ran the inc instruction, increment instruction, and the 0 flag is turned on. Okay, there are other flags that are turned on, but they are not important for us at this point. 0 flag is turned on because we added 1 to a 32-bit number, which means we can't fit the result. And the 33rd bit is the 1, and the rest are all 0, right? Okay, let me explain it here. We have 1, 1, 1, 32 times, and we add a 1 to it. You will have 32 zeros, and then here is 1. Okay, so this is 32. Okay, there are 32 zeros here, and because we are dealing with a word of 4 bytes, the answer is only 0 in this case. Okay, this is the kind of a carry bit. But we don't see the carry bit turned on here. We don't see CF bit turned on when we did the inc statement. Okay. Now let's try with the add statement, which is the very next statement, right? These two statements we will illustrate now. Okay, so let's execute the move. Okay, move should not change anything. So flags will remain the same. And now let's do the add, which is the next instruction. As you can see, we can print the EAP. You can see what it is, or examine the EAP. It's going to be the add instruction. So let's look at the add now and look at the flags. What you can see here is that the 0 flag is turned on, which is the same here. Okay, but the carry flag is turned on. Okay, the reason why carry flag is turned on is that we got a carry of 1, which is turned on only when you are using the add instruction. So by design, add instruction sets the carry flag if adding the two numbers result in a carry. But if the inc instruction doesn't do that, it's because inc is usually used in the loop index, and you would like to preserve the carry flag, which is happening within the loop. So add is the only instruction that will set the carry flag in comparison to inc, I mean. Okay, that's basically the difference between add and inc. Apart from other small differences, let me explain very quickly. We can do disassemble this and look at the inc instruction. The inc instruction has only 1 byte. Okay, 40 means inc EAX. On the other hand, add of 1 to EAX is basically 83, C0, and 1. Okay, so add needs more bytes comparison to inc, of course. That's the difference between add and inc in terms of byte size. To sum up, what we learned is that inc is essentially same as add, except that the carry flag is not set by inc. Only add sets it if there is a carry. That's all. Thank you very much for your attention.